Hello everyone, I'm Daner Kim, your instructor for today and tomorrow. Today we are going for the lecture 7, and we are going to review what is function, and then we are going to study about object-oriented programming. For today, we are just going to look at the concepts, and for tomorrow, we are going to code together by looking at more difficult concepts of the class, objects, instances, inheritance, polymorphism, and so. I'm junior of Gwangju Institute of Science and Technology in South Korea, and you can put questions on the question board of the Notion, and if there are some personal questions you'd like to ask to me, then you can send email to this email address. So today's objective for the lecture 7 is to review functions, since it might be a bit complex concept. And then we are going for the introduction to the object-oriented programming. Since you have learned what is function from the yesterday's instructor, who Jaehyun Park, I believe that you have learned pretty well. However, since the function and class is closely related, I'm going to review once again. So function is defined to do tasks. With given input, we are going to write some kinds of codes, like to print something out, do some operations, and then it will return the output or do operations that, and maybe it may not return some kind of output. So basically how this function works, like there would be the name of function defined, and there would be an argument, which it is like type here for a variable, but we usually call it argument. And then with the argument passed, there may be some operations, like it may be like just like print to the screen, or it may be addition, summation, multiplication, matrix multiplication, like those kinds of stops could be done here, or like file input output. And then there might be output. So there should not be actually there might not be any output, but usually there are output with the return statement. So you write here what you like to return. So with the given input x, we go through the function f, and we get the output. So we are going to look at some functions with other kinds of structures. As I've said here, there might not be a return statement, but there might not be no argument here. There might be no argument here. So functions with no variable, so no argument, then it means that the argument, like the variable and return value, is not actually necessary. Like there are some functions like all of the x constitute the same y, which means the constant function. But that means that the codomain is not really, codomain may be like, there may be like some space. However, the output might not be actually affected by x. So we may call these kinds of stops as identical functions or constant functions. Also, as I've said just before, there are functions with no return statement. So we can like write like return 0. That means like the add 10.25 returns 0. However, we only need this print statement, so we can just remove the return statement here, and it actually basically gets the same statement. However, as you print out the a, which is retrieving the output from the add function, since it gets nothing, since there's no return statement, it returns none. So as we've just checked out, no argument, no variable, and no return statement, there may be some function with no return and no variable, no argument statements. So the function with no return or variable is also possible, like just like typing print hola or hello, like those kinds of stuff would be possible by just outputting hola. there are a lot of there might be a lot of variables. So like there are a lot of variables arguments passed through the here, and like we might be like really confusing like which is which. So we can write this a pointer. We call this like asterisk or star. Like there are various statements, but we will just call this asterisk. So this using asterisk in front of the tuple means it actually gets the list of arrays, the list of elements, which means the tuple of elements. And in the like C language, we call this pointer. So it actually receives the argument as the address of this tuple, since all of those list tuple, like all those data types are like constituted of class. So basically it is just address, but you can just think it as multiple elements. So when it gets the elements, you can just write it like this. So you can basically make the code look simple. And there may be more than one return statement. So by like using this as tuple, when there are multiple operations ongoing, however, you can get the multiple return values, since like just writing comma between them means tuple. So actually it is returning multiple values, but actually the return function is actually return statement is actually returning one tuple value, as here. Like this one asterisk ola means that one tuple to be the argument, and here basically it returns the one tuple return values. And as the tuple auto unboxing is executed, we can think of it as multiple values to be returned. So to wrap up this, we can write a function with the whatever name you choose, and then you can give arguments, and there may be multiple argument values. So you can use asterisk arg3, and there you can write function operations if you want, and you can write return statement, but it is also optional. So for now, like we have just completed the review of the function. So we've just reviewed what was function, and we're going to look at what is the object-oriented program. So let's dive into the introduction of OP. So this is our objective. So what is class? Basically, this class is like the blueprint of some building. So in like, there may be like lots of functions, but they may have similar structures. So in order to frequently use our functions, we are going to use the classes for convenience. So like there are the casting of the muffin, so we call that as class. And by instantiating, we can make actual muffin. We call this instantiating to be like making the class available on the memory, like with each distinguishing objects. So that's how we distinguish between class and object. So the reason why we need class and object, when we need just one calculator, we can just define function with add num, and with the and by repeatedly like adding, we can get the desired result. However, if we define multiple addition function with the global variable calculator 1 and calculator 2, like we may not get the desired result, since we need to distinguish each object, each function. And it is really ineffective, since like each distinguished function should be defined repeatedly, even if they have the same structure. So that's where the object-oriented programming comes in. We can define 3 calculators from one class. So we can define class calculator by defining a plus method and minus method. So these kinds of functions are called method. And by using this self, we can represent multiple calculators by repeatedly declaring the objects from the class constructor. So so now I'm going to explain the basic stuff about the class. So this self is used for any object, so it indicates the object you are going to make. And by using this init method, we call this constructor. So whenever you instantiate the object, the initiator, the constructor is executed for the first time. So the result, the member variable is set to 0 here. And all those functions would be like defined. And we call this method. This method is the function defined in class. So we can execute it by using the dot operator here, just behind the object. So we can declare the method here, and by concatenating them, we can make the class. And this class is made of plus, minus, multiplication, division, and we can set the numbers. So by using these methods and variables with the constructor, we can efficiently define what is the class, and we can instantiate those objects by using these classes. Also, you would have just checked out what is modules and what is classes. I know that the module had been explained thoroughly by Zaehyun Park instructor. However, let's just like check it out. Like we have like used functions and classes, but we need to save them for like various situations. Like there might be like some situations where we should use the classes that had been defined before. So we can make them modularized, so we can just like import them from anywhere. And those kinds of stuffs are called modules, and they are all made of classes. And inside the classes, we have functions, and inside the functions, we have those kinds of functional statements with variables. So that's the basic structure of object-oriented programming. And there are more difficult methods about difficult stuffs about inheritance, like stacking method, or the like super, which means the inherited classes. And there are polymorphism, which means like overriding this classes, overriding the methods from the inherited classes. Like those stuffs should be thoroughly explained. And since those kinds of explanation is really efficient with the code, I'm going to explain it for the next time of the class, which will be the lecture 8 that's going to be premiered through YouTube tomorrow. And I hope you to like review all those ideas and concepts. And I know there are like difficult concepts, and I know the reason why I am not really going through really deep with OOP for the first day is because this OOP concept might be a bit difficult for some students to understand. So I hope you review these concepts thoroughly, and let's meet tomorrow. And we are going to code, we're going to go through the actual codes to understand what is class and what is object and what is polymorphism and what is like special functions and all those stuffs. So thank you so much.